Good evening to all of you. Once again, welcome to your physics class, and this is your own channel, the Chip Physics Point. So, what is the topic of day? The topic of day is electric potential due to an electric dipole on its axial line. So, let me note down the topic on the board. Okay, this is the topic. The electric potential due to an electric dipole on its axial line. So, we already know about the electric dipole and also the axial or equatorial line of the dipole. So, let me draw a diagram of a dipole here. So, this is the dipole. So, according to the definition, a dipole is made by two equal and opposite charges separated by a certain distance, that is 2a. So, minus q and plus q are the charges of dipole. Dipole is AB and the separation between charges is 2a. This is the separation. So, this is the dipole. Now, we take a point P where the potential is required on the axial line of dipole. So you already know that the axial line of dipole is that which joining the charges of the dipole, that is this line. So the point P is here, this point, and this is the center of dipole, and the distance of observation point P is R. तो चलिए बात करते हैं कि हमें इस एक्सियल लाइन पे फाइंड आउट करने के लिए हमें क्या करना होगा. तो वी ऑलरेडी नो दैट द फॉर्मूला ऑफ द इलेक्ट्रिक पोटेंशियल ड्यू टू अ पॉइंट चार्ज क्या होता है फॉर्मूला B equals to 1/4 pi epsilon naught if the charge is q and the distance is r. Then this is the formula. तो हम क्या कर सकते हैं, we have to calculate the potential at the point P due to each charge of the dipole. प्लस चार्ज की वजह से फाइंड करना पड़ेगा, माइनस चार्ज की वजह से फाइंड करना पड़ेगा, और हमें क्या पता है, द इलेक्ट्रिक पोटेंशियल इज ए स्केलर क्वांटिटी. सो द अलजेब्रिक सम ऑफ द इलेक्ट्रिक पोटेंशियल ड्यू टू द बोथ माइनस क्यू चार्ज एंड प्लस क्यू चार्ज मस्ट बी एडेड टू फाइंड आउट द रिजल्टेंट पोटेंशियल एट द पॉइंट पी. तो हम वही करने वाले हैं, माइनस क्यू चार्ज की वजह से पोटेंशियल निकालेंगे पी पॉइंट पे, प्लस क्यू चार्ज की वजह से निकालेंगे और दोनों को ऐड कर देंगे, जो रिजल्ट होगा आ जाएगा. देखते हैं कैसे. सबसे पहले डायग्राम को क्लियर कर लेते हैं. जब हम माइनस क्यू चार्ज से निकालेंगे तो हमें डिस्टेंस चाहिए होगी चार्ज से पॉइंट की, वो कितनी होगी, दिस डिस्टेंस. आर तो सेंटर तक की ऑलरेडी है. दिस इज द हाफ लेंथ ऑफ द डाइपोल फॉर 2a है, तो a इधर और a उधर, तो यहां तक आर हो गई, a और आगे है, तो दिस इज आर प्लस a, डिस्टेंस ऑफ द ऑब्जर्वेशन पॉइंट फ्रॉम द नेगेटिव चार्ज. और अगर पॉजिटिव की बात करें तो पॉजिटिव यहाँ पे है, तो ये डिस्टेंस कितनी होगी, यहाँ तक की आर है, इसमें से ए को फर्स्ट टेक कर देंगे, तो इट इज आर माइनस ए. लेट मी टेक अ वन शेप ऑफ अ टी, दिस वन. This is too hot. So now the diagram is clear. तो हम सपोज कर लेते हैं, let the potential due to the negative charge is B1 potential at P due to minus Q charge is B1 and plus Q charge if V2, then क्या करना है, हमें दोनों फाइंड आउट कर लेते हैं. तो when 1 is equals to 1/4 pi epsilon naught, the charge is q and this is negative, upon the scalar quantity can be represented with the sign, and the distance is r plus a. देख रहे हैं ना, नेगेटिव चार्ज की पॉइंट P से डिस्टेंस कितनी है, r प्लस ए. सो द फॉर्मूला इज 1/4πε0 q/r. तो r के प्लेस पे यह क्या है, डिस्टेंस. चाहे तो आप डायग्राम को इंडिकेट कर सकते हैं. AP इज इक्वल्स टू r प्लस ए, जैसे मैं यहाँ पे नोट कर देता हूँ. AP इक्वल्स टू r प्लस ए, BP इक्वल्स टू r माइनस ए, and OP is equals to R. These are the distances. So V1 is 1/4πε0 minus Q upon R plus A, and V2 is 1/4πε0. The charge is positive now, and the distance is R minus A. This is the distance. Now the net potential at the point P is V equals to V1 plus V2. You can see when we added these two, V1 and V2, 1/4πε0 is common, Q is also common in both the terms. So it should be written as Q/4πε0 is common. In bracket, the positive term is taken first, that is R minus A plus, now the negative term, this is minus 1/r plus a. Now we can solve this. So value is Q/4πε0 by taking the LCM from the formula a minus b into a plus b is equals to a square minus b square. So this is r minus a and r plus a. So LCM is r square minus a square. On solving, LCM ले लिया. अब जब सॉल्व करेंगे तो क्या आएगा, दिस टर्म इज इन दिस साइड r plus a minus r minus a, but due to this negative sign it become plus r plus a. Now this r is positive and this is negative, it should be cancelled out. The remaining term is V equals to Q/4πε0. The remaining term is 2a here, 2a upon r square minus a square. I think you already know that the dipole moment is a term, that is P, and it is equals to the product of either charge and the separation between the two charges of dipole. So this Q into 2a, because this P is equals to Q into 2a, so we can replace this term of numerator Q into 2a in the terms of dipole moment. Then V become 1/4πε0 P upon r square minus a square. This is the final formula of the electric potential on the axis of a dipole. So we can solve more it. If we already know that dipole is a very small, so as compared to the square of this distance, square of the half length of the dipole is much smaller. So we can write, if r square is much greater than a square, then a square can be neglected. So the remaining term is B equals to 1/4πε0 P upon r square. This is the formula. We also can see here, in case of electric field, the electric field on the axis of an electric dipole is inversely proportional to the cube of the distance of observation point. याद होगा आपको फॉर्मूला क्या था, इलेक्ट्रिक फील्ड on the axis of a dipole is 1/4πε0 2p upon r cube, but here this is r square. So potential is depend upon the square of the distance. So the p is constant for a given dipole, 1/4πε0 is constant, then v is inversely proportional to r square. So the electric potential decreases with the distance, and it is inversely proportional to the distance of the observation point from the center of the dipole. This is the formula for the electric potential due to an electric dipole on its axis. So you can solve it easily, and it is very easy derivation. If you want to note down the theory also, so you can assume theory related to the diagram. As you can write at the start of the derivation, let me consider an electric dipole AB made by two charges minus q and plus q separated by a distance 2a. and the point P is situated on the axial line of dipole, which is at a distance r from its center, where the electric potential is required. To find it, now continue. Let the potential at P due to the -2 charge and +2 charge are B1 and B2. Then putting the values in the formulas of electric potential, we can find the B1 and B2, and the algebraic sum of B1 and B2 gives the final electric potential at the axial line. So this is the topic of day. Now we will meet in our next class. Till then, goodbye.